Here we are going to solve Leetcode problem number 2, add two numbers. This is a problem on linked list. So we are given two non-empty linked lists representing two non-negative integers, and the digits are stored in reverse order, and each of their nodes contain a single digit. So if the number is 342 and these digits are stored in reverse order, so 2 is placed at the starting position and 4 is in the middle, 3 is at the end. Okay, and what we need, similarly we'll have another number which is 465, and again these numbers are also stored in the reverse direction. So what we need to do is we need to add these two numbers and return the result in the form of linked list. Okay, so if I take the numbers in the reverse direction, so 243 will be our starting number, 564 is going to be second number, and if we add 2 plus 5 is 7 and 4 plus 6 is 10, 1 will go as a carry to this and a 0 is added here, and it's going to be 4 plus 4, which is 8. This is what we need to return. Okay, now let's see how we can implement this problem. So I've kept a pseudocode here which will be helpful to understand the problem. So initially we will take two pointers. So pointer 1 will be used to traverse through list L1 and pointer 2 is used to traverse through L2. Okay, and we'll take value at the pointer 1 and value at the pointer 2 and we'll add them. So the sum is going to be value at pointer 1 plus value at pointer 2 plus carry. Every number will have a carry. Initially, as these numbers or the starting numbers, we will not have any carry, so carry is going to be 0 at this point. Okay, so it's going to be 2 plus 5, 2 plus 5 plus 0, that's going to be 7. Okay, and we will add this value to the target. So target is our final list which we want to return. Okay, for the target we will not directly add sum, instead we will do a modulus of 10 and then add that number, because let's say if the sum is 17, if we receive a sum as 17, then we cannot add 17 to the target list, because in the problem we are given a constraint that each node will hold only one digit. Okay, and so what we do is we'll just do a modulus of 10 and that will be 1 and then 10, so we'll have a remainder of 7. So this remainder goes into our target, and after that carry will be this coefficient. Okay, so carry is going to be sum divided by 10. Okay, and we'll increment our both the pointers. So pointer 1 moves here and pointer 2 moves here. Now we will add 4 and carry from the previous iteration, that's 0. Now we'll add 4 plus 6, that's going to be 4 plus 6 plus carry is 0, so sum is 10. Okay, now what we'll do is for the target, so 10 that's going to be 1 0, so the remainder is 0, so remainder 0 gets added here and carry is going to be 1 here. Okay, carry will be updated to 1. Now we'll move our pointers, p1 will be here, p2 will be here. Okay, now carry we have as 1, so what we will do is 3 plus 4 plus 1, which is 8, because this one is carry from our previous iteration. Okay, so we will take 8, so we got sum as 8. Now what we will do is we will repeat the same process. We will take 8 and then 10 0 0 8, so 8 gets added to the target, so 708, and carry, there is no carry for this, it's 0. If there is any carry, for instance, then you have to add the carry as the last number. Okay, and that's it, that's how we solve this problem, and this is the expected output. 708 is the expected output. Okay, and one other thing that we do here is, as you can see, list L1 and L2 are of same size. We could have a scenario like list L1 will be something like this and list L2 will be something like this, right? And at this point when you add these four numbers, these two numbers, what we do is we can just take rest of the numbers and add it to the list, or to make the problem simple. So if you do not see any value for any values in the list 1, then you can just make it 0, because there is no impact, right? So this is how we will solve this problem. What we will do is we will make both the lists equal and then try to add both the lists. Okay. Okay, now let's see how we can implement this problem. So initially, so L1 is going to be 2, 4, 3, and L2 is 5, 6, 7. So what if we are given only L1 and L2 is empty? At that point of time, there is nothing to add, so we can just return L1, right? So that's going to be like, if L1 is equal to null, then we can just return L2 as our output. Similarly, if L2 is equal to null, then we can return L1 as our output. Once if we know that both L1 and L2 are not empty, then what we need to do is we need to have two pointers, one pointer for L1, another pointer for L2. Okay, so list node pointer 1 is going to be L1, and list node pointer 2 is going to be L2. Here, as this is just a pointer, it will not need any space or anything. Okay, so this way we're making sure that we're not changing the given input. Okay, now once we have p1 and p2 pointers created, what we need to do is we need to traverse through the list L1 and L2 with the help of p1 and p2. So this is how we'll do it. So while p1 not equal to null, or p2 not equal to null. So there could be a scenario that we are given with a list like this, right? We only have one element in L1 and three elements in L2. So we have to process both L1 and L2. So in this case, once we add the value of 2 with 5, 7, in the next iteration, L2 will be moved to the next position, which is 6. And at this point, there is nothing in L1 to add. Okay, so what I'm planning to do is we will make these two lists equal by adding zeros to it. Okay, if we add zeros, there won't be any impact, right? First of all, I will take the p1 value. That's going to be int p1 value is going to be, if p1 is equal to null, then what I will do is I'll take 0. Otherwise, I'll take p1 dot val. Okay, I hope that makes sense. If there is no, if p1 node is empty, then we are storing p1 value as 0. Otherwise, we're just getting the actual value of p1. Sorry, this is going to be p1. Okay, similarly, in p2 value is going to be, if p2 is null, then we'll add 0 to it. Otherwise, we'll take p2 dot val. Okay, now once we have p1 and p2, what we'll do is we'll just add them. So int sum is going to be p1 value plus p2 value, plus we'll have to take the carry, because every number will have a carry. Initially, we can initialize carry as 0. Okay, once we calculate sum, let's say in this situation 2 plus 5 is 7, we will add that in the target list. So we will create a new list which we will be using as a target. Okay, so that's going to be list node. So I'll take as head node for the target, and I will create a new node on the space. I'll take it as -1, and I'll take another pointer tail, and I'll point it to the head, and I'll make use of this tail pointer to move through the target. Okay, so if I take an example of this, so initially what I'm doing is I have created head and tail pointers which are pointing at -1. Okay, and in my first iteration my sum is 7, and for this what I will do is I'll create a new node, list node. Node is going to be new list node of, I will take sum modulus 10. Okay, as we have seen in the explanation, we will be doing a modulus of 10 and add that in the node. Now the new node is created. So this is the node which we have created here. Now what we need to do is we need to point this tail node to this new node. So how do we point that? So that's going to be tail dot next is going to be, so I'll take it as a new node. So tail dot next is going to be new node, and tail is going to be new node. So my tail pointer will be moved from here to here. Okay, and after that what we'll have to do is we'll have to update our carry. So carry is going to be sum by 10. Now we are done with values 2 and 5, and we have to move our pointers p1 and p to the next value. So that's going to be if p1 not equal to null. We have to do this null check, otherwise we might encounter null pointer exception if there is no value. In this case, if there is no value, and if you do a p1 is equal to p1 dot next, that's going to return. So that will create a null pointer exception. Okay, so p1 is going to be p1 dot next. Similarly, if p2 is not null, then p2 is going to be p2 dot next. Okay, let's change the input back to 2 4 3, and in the second iteration we are having p1 value as 4, p2 value as 6. So that's going to be 4 plus 6 plus carry as 0. So 4 plus 6 is 10. So we will do a modulus of 10. So 0 gets added. So we have created a new node with 0, and we will point this tail pointer to that new node, and we will take the carry as 1, and we'll repeat the same process. Now 3 plus 7 is 10. 10 plus we already have a carry of 1, so that's going to be 11. So 11 modulus 10 is again that's going to be 1, and we have a carry left to be 1. After that, what we will do is we'll move our tail pointer to this place. Now at this point we have covered both L1 and L2. We are done with this. So we will be exiting out of this loop. However, we are still left with a carry of 1. So if you are still left with a carry, then what we need to do is we need to create another node for that carry. So something like this, and we have to move our tail pointer to that carry node. So tail will be moved to the carry node. Okay. So how do we do it? After processing this, if carry is not equal to 0, then what we will do is we'll create a new node. New node is going to be new list node with the carry. Okay, and same process, tail dot next is going to be new node, tail is going to be new node, and at the end we have to return the pointer of the resulting array. So if you see, our tail pointer is at the end. If you return tail pointer, there is no way that you can traverse to the resulting array, right? So that's the reason we'll have our head pointer which is not changed. So what we return is head dot next. So basically we are returning the starting pointer as this. Now with the help of the starting pointer, we can traverse through the entire list. So let me remove the comments and run the code, submit. This works. So this is how we can solve this problem. Thank you for watching the video, and we'll see you in another problem. Thank you.